Hello guys, and today I'm going to show you the laws of motion, 3 laws of motion that were created by Sir Isaac Newton, as he discovered that for physics, 3 laws of motion when it comes to force outside and on objects and what happens and all that. And I will show you 3 experiments today on that. So the first law of motion by Isaac Newton is an object in motion tends to stay in motion, and that's usually unless something acts on it outside, like a force moves the object. Like it'll stay in motion unless something acts upon it, like a force. And I'm going to show you today with this experiment. So first off, you got the puck, and now see how it moves and it doesn't move very far? That's because the friction under it is slowing it down. So to make it move better, we're gonna, reduce the friction, and that's where the balloon comes in. So as you can see here that, sorry, my English is off. So as you can see here, I blew up this balloon, I put it onto here, and now the puck has a little hole through here where air comes out, right here. And when I place it on the table, it goes like this. You can't quite see it, the balloon's too big, but the puck moves easier now because there are less friction slowing it down when you push it. So when you do that, now, like I said before, an object in motion tends to stay in motion unless acted upon by an outside force, like my hand pushing it. And seeing it move smoothly, like I said, less friction. So that is Newton's first law, and there you go. Okay, so for Isaac's second law of motion, we're dealing with the greater the mass, the greater the force. Now, this baseball is heavier than this foosball, so obviously this is going to cause more force because it's heavier. So like, see the foosball, as it hits the table, it does this. Alright, you see that? And now with the baseball, do this. That's harder in force. Now you know why. Like, you'd probably rather catch a baseball than catch a bowling ball. And I'm sure I'll let you do the math. And the same thing, if you were to throw one of these, acceleration, the more acceleration the object has as you throw it, the greater the force. So it's a pretty simple one, and second law of motion. So now for Isaac's third law of motion, which is the last one, is for every action there's an equal but opposite reaction. And the action will be that the air is jetting out of the balloon. I'm going to blow it up in a minute to show you. And the reaction, which is like opposite, is the car that moves because the air is going out of the balloon, but it's making the car move. So let me show you. So pretty simple. Now I already blew up the balloon. The air comes out of here, but I'm holding my thumb on it so the air doesn't go out. So the action, remember, is the air leaving the balloon. Reaction, the car will be moving. So for every action, there's a equal but opposite reaction. Here we go. Fell off the table, but you get the idea. Those are the 3 laws of Isaac Newton's motions, So there are other experiments you can do with that kind of stuff to show another example of the 3 steps. So don't think this is the only, and I'm sure you guys already know that, but I just want to say it but yeah, make sure you like, comment, subscribe, and share, and we'll see you guys later.